Hello, good morning. I'm Aishwarya Rajendran and we are from Group 1. So today we're gonna present about liquid level monitoring. So, these are all my teammates. So first, myself, Aishwarya Rajendran, so my metric number CN190226, and my colleague Muhammad Nazmi bin Abdul Rahim, CN190104. And the other person is Ahmad Amirul Afiq bin Muhammad Fauzi, CN190130. So, okay, what is the basic view of our project is basically it's about water tank controller. So as you can see, there is actually we have labeled that pool, but actually it is tank 1, and the another segment is tank 2. So we have PLC and we have a pump. Okay, as you can see, LLS stands for lower level switch and HLS stands for high level switch. So before we begin with our project, as we all know, we have to know the logic behind our project before we proceed it. So in real life application, there is several research on this. Example, piping and instrumentation diagrams, internal wiring diagrams, and so on. In this process, the pump should transfer the water from tank 1 to tank 2 automatically. So that's the function, basically what we're going to see about. So how does a pump transfer water from tank 1 to tank 2 using PLC? So as we are telling that we are using PLC, which means automatically. So as the water level increases, reaches high level switch, the pump switch off automatically. So there's no human power needed. And same goes to when the water stands at low level switch, the pump should start automatically without humans help. So the exact procedure that we're going to do is about PLC, which controls the water from the pump when should close and when should open. As simple as that. So as we can see in next picture, okay, as I mentioned before, that's the lower level switch where as soon as the lower level switch under tank 2, which means I'm showing an arrow there, so tank 2 does not sense any water. So when there's no water, basically in simple English we could say that when there's no water in tank 2, so the PLC, our program PLC, should send command to the pump where the pump should open so that the water could refill the tank. Okay, so that's what we're gonna do. Then the PLC will send stop command to the pump when the water reaches high level switch. All right, okay. Then once the pump shut down, when the water reaches high level switch, it remains shut down till the water goes down back to lower level switch and there's no presence of water or there's no sense of water, and the PLC will sending a command to pump again to on the water tank. Okay, next. Okay, that's our pump where I'm showing this arrow there. So that's our pump. So this procedure will repeat again and again. You know, as you can see, when there's no water, so there will be command to the PLC. PLC will send the command to the pump, and the pump will on the water. So the tank will be full. So once it reaches the higher level switch, the the PLC will send command close to the pump, and the pump will switch off. Okay, this process will repeat again and again. The result when the situation where PLC will shut down the PLC itself will shut down when there is no water in tank 1 itself. So when there's no water in tank 1 itself, the PLC will shut down immediately because there's like no source of water. Okay, so this will be when there is no water in tank 1 and its low level switch does not sense any water. So in a simpler English, we could say that when there's no presence of water in tank 1, automatically PLC will shut down or remain closed because there's no source of water to pressurize or to pump to tank number 2. Okay, this is basically theoretical wise. So as theoretical wise, we could do a lot of research about it, but we have to do it practically so that we could see it more clearly. Okay, so basically about theoretically side, I have explained it to y'all. So about practically side, my behalf teammate will explain on it. Okay, so that's all from me. So once again, I'm Aishwarya. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day to my beloved lecturer and my dear friend. My name is Ahmad Amirul Afiq bin Muhammad Fauzi, metric number CN 190130. So I will explain about objective of this project. So basically the project goal should be measurable at the conclusion of project and should be attainable, time-bound and detailed. So there are few objectives based on our project. The first point, the objective is to control the level of water and avoid wastage in the tank by using PLC sensor and motor. Bermaksud kat sini, objektif projek ini dilakukan ialah untuk mengawal paras air di dalam tank dan mengelakkan pembaziran dengan mengawal menggunakan PLC, sensor dan motor. Seterusnya, to reduce time consumption and human resource so that people can do other tasks in their daily life. Maksud kat sini, penggunaan masa dan tenaga kerja dapat dijimatkan agar pekerja atau manusia dapat melakukan kerjaan yang lain. The next point is to increase product revenue and greater accessibility or more security by controlling the level of water. So for the next part is list of equipment, consists of input and output equipment. So for the input equipment consists of off push button and on push button. Each of them with quantity is 1. So we move to the next. Output equipment consists of valve tank 1, valve tank 2, timer contact, in bracket timer 00, and lastly timer contact in bracket timer 001. So each of them with quantity 1. So to complete our project, we are using Programmable Logic Controller PLC software.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Nazmi bin Abdul Rahim from Group 1. So our group is build level monitoring system by using CS Programmer PLC. So in my screen, we could see the PLC system. So this is in rung 0. This is off button and on button for the input. So the off button is normally closed. So for the output, in run 0 we have valve tank 1. So when we on the button, it will send signal to valve tank 1 to open the valve, so the fluid can go to the tank. So in the rung 1, the address is same from the output from valve tank 1. So if valve tank 1 is on, so the load on the in rung 1 is also on simultaneously. So it will send signal to the timer, and this is our timer for the output, and I set it at 5 seconds, hashtag 50 for 5 seconds. So in real situation, we maybe can set the timer 1 minute or more than that. So if we set more than 1 minute, maybe the tank is bigger than maybe the tank is bigger. So in this simulation, I just set it for 5 seconds only. So if the timer is triggered, so the valve tank 1 is will close. So the valve tank 1 will close. So after that, in rung 2, this is the timer contact. I name it as a timer contact, and the address is same with the timer, which is timer 000. So after the timer on the rung 1 is triggered, so the timer contact on the rung 2 is also triggered. So it will send the signal to valve tank 2, which is valve tank 2 will open to let the fluid go into the tank. After that, on the rung 3, we see the valve tank 2, the load in here, and the address is the same with the valve tank 2 on the rung 2. So the valve tank 2 is on simultaneously with the load in rung 3. So it will send the signal to the timer. The output is here. The timer is, I also set the timer for 5 seconds to trigger the valve tank 2 to close after it open, and after 5 seconds the timer is triggered and the valve tank 2 is closed to prevent the fluid to go out. So after we push off the off button, the system will shut down. So I gonna show some simulation. On the Work Online simulator. So this is the initial condition of our system. So if we turn on the button, the valve tank 1 will open, and the timer will set for 5 seconds to close the valve tank 1. And the valve tank 2, after that, after 5 seconds, the timer 1 is triggered, the valve tank 2 is open, and we could see the timer on the valve tank 2 is triggered, and the valve tank 2 is after 5 seconds the valve tank 2 is closed. So this is our system. So if we trigger the off button, the system will shut down. These two valve tank is not operate, even the on button is triggered. That's all from me. Thank you.
For the conclusion part, we can conclude that a solution of water level control system using PLC is proposed, designed, implemented, and tested. The benefits of a design supported a PLC are simplicity, flexible. The water level system using PLC may be simple one, combining and programmable logic controller. By carrying out such research, we could reduce the water from wastage. After this project is completed, we are able to control the level of water and avoid wastage of water in the tank. Moreover, we managed to reduce time consumption and human resource consumption so that people can do other various tasks. Last but not least, based on this project, the product revenue and accessibility can be increased and greater or more secure. I think that's all from us. Thank you.